Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 12, Linear Equations in Two Variables. Okay, so there's an opening exercise here. It says, Emily tells you that she scored 32 points in a basketball game. Write down all the possible ways she could have scored 32 with only 2 and 3 point baskets. Use the table below to organize your work. Okay, so the first thing I would do is think of just 2-pointers. Because 3 will not go into 32 evenly. 32 is even, so 2 will. So 32 divided by 2 is 16. So she could get 16 2-pointers, and that adds up to 32. And so therefore 0 3-pointers. So this would be 16 times 2. So this is really like 2x. You get 2 points for x, and you get 3 points for y. So 16 times 2 plus 0, 3 times 0, if you plugged in 0 for y, would be 32. So then if I can't go any higher than 16 2-pointers, so now I'm decreasing. So if I get 15 2-pointers, 15 times 2 is 30. But I can't get any 3-pointers to add up to 32, so 15 won't work. So then if I take 14 divided by 2, or times 2, I get 28. And 28 plus 4 is 32. So that would be 1 3-pointer and then a 1-pointer, so that's not going to work. 13 times 2 is 26. 32 minus 26 is 6, and that is a factor of 3. So 13 will work. So 13 2-pointers will give me 26 points, and 2 3-pointers will give me 6, and 26 plus 6 is 32. So I decreased by 3 and increased by 2. And then we're going to look for a pattern. I've already discovered it, but I'm going to keep going here. So now I was on 13. So if I get 12 2-pointers times 2, that will give me 24 points. 32 minus 24 is 8, and 3 will not go into 8 evenly. So then I'm going to go to 11 2-pointers, would give me 22 points. 32 minus 22 is 10, and 3 will not go into 10, so 11 did not work. If I get 10 2-pointers, that will give me 20 points. I want 32, so if I subtract 20 from 32, I need 12 more points. That's a factor of 3. 4 times 3 is 12, so 4 3-pointers. Actually, let me stay with red here. 4 3-pointers. And 10 2-pointers. So see, we went from 16 down to 13. That's a decrease of 3, a decrease of 3, an increase of 2, an increase of 2. So now I've got the pattern. If I decrease 10 by 3, and decrease 7 by 3, and decrease 4 by 3, and add 2 each time, and then I would still want to check at the end. So this is worth 2 points, and this is worth 30. 2 plus 30 is 32. So it works. So there you have it. There is all the possible combinations of 2 and 3-pointers that would add up to 32 points. 6 different ways. Now it says, let x be the number of 2-pointers and y be the number of 3-pointers that Emily scored. Write an equation to represent the situation. So that would be 2 times the number of 2-pointers is x. And they're worth 2 points each. So 2 points times however many you get. If you don't get any 2-pointers, 2 times 0 is 0. If you get 1 2-pointer, 2 times 1 is 2, and so on. Okay, and then we add that to the number of 3-pointers is y. 3y. Write an equation to represent the situation. So you needed 2x plus 3y, and our total was this 32 up here. So 2x plus 3y equals 32, and that's what I was showing you up here. So there's our equation. So if I plug in 10, 20. Plug in 4, 12. 20 plus 12, 32. Okay, exploratory challenge. Find 5 solutions for the linear equation x plus y equals 3 and plot the solutions as points on the coordinate plane. So I'm going to go back here and show you what happened. Once you find a pattern, it is going to continue. So that was a decrease of 3, and that was an increase of 2, and that's going to happen every single time after the first, because it has to form a straight line. And if it changes, the line turns, and it is no longer a line. So now it says find 5 solutions to this linear equation, and plot the solutions as points on the coordinate plane. So I always like to start with 0. 0 is easy to work with. So if x is 0, 0 plus 3 equals 3. So I would say 0 plus y equals 3 here, and therefore y has to be 3. Okay, so now I'm going to choose 1. So now I know my x is 1. 1 plus some number equals 3. And 1 plus 2 equals 3, so that's going to be 2. So now I have a pattern. This is increasing by 1, this is decreasing by 1, and that is going to continue. So if I choose 2, that would mean 2 plus some y equals 3, and 2 plus 1 is 3. 3 plus some y equals 3. Well, y has to be 0. 3 plus 0. And if I go to 4, 4 plus some y equals 3. Well, now y has to be negative 1. Okay, so there we have it. Increase 1, increase 1, increase 1, decrease 1, decrease 1, decrease 1. Number 2. So we're going to continue with this. And I would always start with the variable that has a coefficient to get rid of that coefficient so it's easier to add or subtract. Okay, so I'm going to plug in 0 for x the first time. I like choosing 0. It makes it easier. So if I make x 0, this would be 2 times 0 minus y equals 10, or 0 minus y equals 10. So therefore, let me move this up. So that just means negative y equals 10. So if I multiply both sides by negative 1, I get y equals negative 10. Okay, so now I'm going to choose 1. 2 times 1 minus y equals 10. 2 minus y equals 10. Subtract 2 from both sides, I get negative y equals 8. So y equals negative 8. I'm going to continue this just because this is new, but I already know the pattern. X is increasing by 1 and y is decreasing by 2. Number 2. If I substitute in 2, I get 2 times 2 minus y equals 10. 4 minus y equals 10. Negative y equals, subtract 4 from both sides, we get 6. Multiply both sides by negative 1, and y equals negative 6. So it's decreasing by 2 again. So 3 should be negative 4, and 4 should be negative 2. But I'm still going to check. 2 times 3 minus y equals 10. 6 minus y equals 10. Subtract 6 from both sides. Negative y equals 4. Y equals negative 4. And there it is. 2 times 4 minus y equals 10. 8 minus y equals 10. Subtract 8 from both sides, and I get 2. And multiply by negative 1 on both sides, and negative y becomes positive, and 2 becomes negative. And there's my negative 2. Okay, in this one it says find 5 solutions for the linear equation x plus 5y equals 21, and plot the solutions as points on the coordinate plane. So I have 5 y's. Let's make our life easier here, and we're going to substitute in values for y and find x, because it's easier to plug in a value here and get a multiple of 5 so I'm not dealing with fractions. So I'm going to try to get rid of this. So if I say y is 0, 5 times 0 is 0, x plus 0 equals 21, therefore x equals 21. So when y is 0, x has to be 21. So it's easier to plug in a value if one of these two has a number other than 1 as a coefficient. substitute in for the number to calculate the multiplication before addition. Okay, so I'm going to take x plus 5. Now I'm going to make my y 1. And if I make y 1, then it's 5 times 1 equals 21. So then I get x plus 5. 5 times 1 is 5 equals 21. Subtract 5 from both sides, and I get x to equal 16. So there's 16. Now I've only had to do 1 to find my pattern. So if I increase by 1, I'm decreasing by 5. And notice the numbers up here. This increases by 1, this decreases by the 5, that's the coefficient. So this decreases by 5, I should get 11, 6, and 1. So let's take a look. X plus 5 times my y, 2, equals 21. X plus 10 equals 21. Subtract 10 from both sides, and x does equal 11. X plus 5 times 3 equals 21. X plus 15 equals 21. Subtract 15 from both sides. 21 minus 15 is 6. X plus 5 times 4 equals 21. X plus 20 equals 21. Subtract 20 from both sides, and sure enough, we got that 1. Okay, so now it says consider the linear equation 2/5 x plus y equals 11. A, will you choose to fix values for x or y? So I look up here, y is 1, and x is 2/5. So if I choose values for x, I can get rid of this fraction, and it makes it easier. So I will choose value for x because if I choose values for x in multiples of 5, then I remove the fraction. Okay, and it says, are there specific numbers that would make your computational work easier? Explain. So I already have. The answer to that is yes. If I multiply 2/5 times 5, think of 5 as 5 over 1. The 5's cancel, and it equals 2. 2/5 times 10 over 1 equals, you could either do it that way by reducing, or this also means 20 over 5, which equals 4. So if I do multiples of 10, 2/5 times 15 over 1, this 5 will make that 5 a 3, and I get 6. So if I do multiples of 5, the fraction goes away. Always choose values that match the denominator, multiples of the denominator. All right, part C. Here we go. There it is. Y equals 2/5, or 2/5 x plus y equals 11. So I'm going to choose a value. I can always start with 0. I always like starting with 0 because 2/5 times 0 is 0. So if I have 2/5 times 0 plus y equals 11, then I get 0 plus y equals 11, so therefore y equals 11. So there's my first point. But now if I have 2/5, remember the denominator is 5, I want to choose multiples of 5. So I'm going to choose 5. Plus y equals 11, so x is 5. These cancel. 2 plus y equals 11, subtract 2, and y equals 9. So now I already have my pattern. If I choose multiples of 5, 10, 15, and 20, I'm decreasing by 2. So these should be my values. So 2/5 times 10 plus y equals 11. This makes it a 2. 4 plus y equals 11. Subtract 4, and y is 7. 2/5 times 15 plus y equals 11. This becomes a 3. 6 plus y equals 11. Y equals 5. 2/5 times 20 plus y equals 11. 4 times 2 is 8. 11 minus 8 equals 3. So there are all my values. Okay, number 5. At the store, you see that you can buy a bag of candy for $2 and a drink for $1. Assume you have a total of 35. So we have a total of 35. We have a drink for $1, and we have candy for 2. So we have 2 times C and $1 times D. You are feeling generous and want to buy some snacks for you and your friends. Write an equation in standard form to represent the number of bags of candy, X, and the number of drinks, Y, that you can buy with $35. So they're saying candy X and drinks Y. Candy X and drinks Y. So this equation is 2X plus 1Y, or just Y, equals our total of $35. So part B says to find 5 solutions to that linear equation from part A and plot the solutions as points on the coordinate plane. Okay, so again, my coefficient is 2 here, my coefficient is 1 here. We're going to pick values for the coefficient that is not 1. I always start with 0, so if I don't buy any X, which was candy, how many drinks can I buy? So that is possible. You could just buy drinks, so I'm going to start with 0. So 2 times 0 plus Y equals 35. Y equals 35, because 2 times 0 is 0. So I can buy 35 drinks and no candy. If I buy 1 candy, let me think about this a second. Okay, rather than choosing a pattern here, let's, instead of just going by ones, let's just choose some random values. Let's just say I choose 3. Say I want to buy 3 candies. So that would be 2 times 3 candies plus some number of drinks equals $35. Well, 3 candies is going to cost us $6. And when I subtract 6 from 35, I get 29. So I can buy 29 drinks if I buy 3 candies. And what would happen if I chose, I don't know, 9? So I increased by 3 here, and that decreased by 6. So it's decreasing by double, so this is increasing by 6, so this should decrease by 12. And 29 minus 12 is 17. Now I'm just playing around here and checking to see if this pattern's working. I'm still going to do my work. So $2 times 9 candies plus some drinks equals $35. $18 for the candy leaves me with Y drinks. So Y equals 35 minus 18, and it is 17. So if I choose, I don't know, 14, let's just change it this time. And I will have to do the work. 2 times 14 plus Y equals 35. And 28 plus Y equals 35. Y will then equal 35 minus 28, which is 7. And let's say I buy, I don't know, the maximum number of drinks I can buy, or candies I can buy, is 35 divided by 2, which is 17.5, and I can't buy 17.5, can't buy a half a bag of candy, so I'm going to stop at the maximum 17. So if I take 2 times 17 plus Y equals 35, 2 times 17 is 34, plus Y equals 35, then I see that if I buy 17 bags of candies for $2, it's $34. Then Y is going to equal 1 drink. Okay, so there's multiple values, and now they're asking us to plot it, and they don't give us a grid, so let me get one. Okay, so here's a grid. So keep in mind, whenever we're graphing, we have an x-axis and we have a y-axis. We should always label our coordinates. And when I come up here, candy is X, drinks is Y. We should always label our graphs. We should actually have a title. Candy and drinks at the, what was it, at the movies? Or we could just say candy and drinks for our title. And then X is candy. So this is bags of candy down here. And then across the side, this is drinks. So we should always label our coordinates and our axes, I mean. And this is the origin 0, 0. Okay. So I look at my values, and I'm going up from 0 to 17. I actually can fit this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 is right here. So I have the point 17, 1. So if I make these points, this is the point 0, 35. This is the point 3, 29. And let me do it this way for a reason. 3, 29. Okay. 9, 17. 14, 7. And this is 17, 1. All right. So now that I've done that, I'm just going to move these down so I can see them all. Okay, so here are our values we're graphing. So 0, 35, 0 candies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not going to reach, so I'm going to go in twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, 26, 28, 30. 32, 34, 36 is here, so 35 is halfway. So 35 is right here. And 2, 4, 6, 8, 10. I will label each tenth for now. Okay, so that's 0, 35. So now if I go over to 3, these are in ones over here. So if I go over 3 and up to 29, okay, 30 is right here, so just below 30 would be 29. And then 4, 5, 6, 7, 8, 9 is here. And I need to go up to 10, 20, 19. Okay, 10, 12, 14, 16, and 17 is halfway. And this 29 is also halfway, by the way, because we're going by twos. So that's halfway. And then I choose, so that was 9, 17. So if I go out to 10, 11, 12, 13, 14, and go up to 7, that's 2, 4, 6, and halfway is 7. That's right here. And then finally 17, 1, which is halfway here. So there's my straight line coming down. And that is my linear equation graphed. Okay, that is the end of lesson 12. Review the summary and go do your problem set.